Good morning to one and all. I am Professor Raju Patil, Department of Mechanical Engineering, Angdi Engineering College, Belagavi. So today I welcome you for the today's morning session for the metal cutting and forming. So today I will be conducting for the model 2 slotting machine. Okay. So what is slotter? Okay. Slotter can simply be considered as vertical shaper where the single point or straight or formed cutting tool reciprocates vertically and the workpiece being mounted on the table is given slow longitudinal and or rotary feed. The slotter is used for cutting grooves, keyways, internal and external gears and slots for various shapes. The slotter was first developed in year 1800 by Brunel. Okay, types of slotters. The different types of slotters which are most commonly used in nowadays, those are puncher slotter and precision slotter. So what is puncher slotter? Puncher slotter, it is a heavy rigid machine designed for removal of large amount of metal from large forging or castings. The length of a puncher slotter is sufficiently large. It may be as long as 1800 to 2000 mm. The ram is usually driven by a spiral pinion machine with rack teeth cut on the un underside of the ram. The pinion is driven by a variable speed reversible electric motor similar to that of a planer. The feed is also controlled by a electrical gears. Next one, the precision slotter. It is a lighter machine and is operated at high speeds. The machine is designed to take light cuts. The machine is designed to take light cuts, giving accurate finish. Using special jigs, the machine can handle a number of identical works on a production basis. The precision machines are also used for general purpose work and are usually fitted with Whitworth's quick return mechanism. Okay, so next we'll be discussing about the major parts of the slotter. So you all can see the base here, base which is the very important part on which the whole machine is mounted, and the base is rigidly built to take up all cutting forces and entire loading of machines. The top of the bed is accurately finished to provide guideways on which the saddle is mounted. Guideways are perpendicular to the column face. Okay, next comes column. You all can see this column which is in a vertical position. It is a vertical member which is cast integral with the base and houses driving mechanism of the ram and feeding mechanism. Okay, the front vertical face of the column is accurately finished for providing ways on which the ram reciprocates. And next, coming to saddle, you all can see here this saddle which is situated or mounted above the base or exactly in front of the column. It is mounted upon the guideways and may be moved toward or away from the column either by power or manual, you can say. Okay, manual control to supply the longitudinal feed to the workpiece. The top face of the saddle is accurately finished to provide ways for cross slides. These guideways are perpendicular to the guideways of the base. Okay. Next comes this cross slide. This cross slide, you all can see, it is mounted upon the guideways of saddle and may be moved parallel to face of the column. Movement of the slide may be controlled either by hand or by power to supply the cross feed. Okay, next comes the rotary table. Next comes the this is the rotary table. Okay, this is the rotary table. It is circular table which is mounted on the top of the cross slide. The table may be rotated by rotating a worm which meshes with a worm gear connected to the underside of the table. The rotation of the table may be affected either by hand enables the table to be rotated for indexing or dividing the periphery of a job in equal number of parts. T-slots are cut on the top face of the table for holding the work by different clamping devices. Rotary table enables a circular or contoured surface to be generated on the workpieces. Next comes the RAM. The RAM. It is reciprocating member of machine mounted on the guideways of the column. It is connected to the reciprocating mechanism continued within the column. And next comes the stroke. It carries the tool head at its bottom end. And next comes tool head. Tool head, you all can see here, this is the tool head. Okay, tool head, it holds the tool rigidly. In some machines, special type of tool holders are provided to relieve the tool during its return stroke. Okay, so next comes working of this slaughter. Okay, next comes this working of the slaughter. The vertical ram holding and cutting the tool is reciprocated by a ram driving mechanism. The workpiece to be machined is mounted directly or in a vise on work table. You all can see this work table. Okay, like shaper in slot. Also, the fast cutting motion is imparted to the tool and feed motions to the workpieces. In slaughter, in addition to longitudinal and cross feeds, a rotary feed motions is also provided in work table. The intermittent rotation of the feed rod is derived from the driving shaft with the help of automatic feed mechanism. The intermittent rotation of the feed rod is transmitted to lead screws for linear feeds and two worm wheel for rotating the work table. The working speed is like number of strokes per minute may be changed by changing the belt, pulley ratio or using an additional speed gearbox. Okay, next comes the slaughter operations. Slaughter is most used for machining internal surfaces. First one, internal flat surfaces. Second one, enlargement. First one, you all can see figure A, that this is enlargement or finishing the non-circular holes bounded by number of flat surfaces which have shown in figure A. You all can see the enlargement and finishing of non-circular holes bounded by number of flat surfaces. And in figure B, you all can see blind geometrical holes. You all can see the blind geometrical holes like hexagonal socket as shown in figure. Okay, and in internal grooves and slots of rectangular curved sections, you all can see here. And in figure C, you all can see internal keyways and spines, straight tooth of internal spur gears, internal curved surfaces and internal oil grooves, which are not possible in shaper. This is possible in slaughters. Okay, so specification of slaughter. Slaughter is specified by the following parameters: the diameter, maximum stroke length, and the diameter of a rotary table, maximum travel of saddle and cross slide, type of a drive used, power of the motor, net weight of the machine, number and amount of feeds, floor area required. Next comes drilling. So what is drilling? Drilling is the process of originating holes in the workpiece by using rotating cutter called drill. The machine used for this purpose is called drilling machine. Although it was primarily des designed to originate a hole, it can perform a number of similar operations. In a drilling machine, holes may be drilled quickly at at low cost. As the machine tool exerts vertical pressure to originate a hole, it is also called as a drill press. Holes were drilled by Egyptians in 1200 BC by bow drills. The bow drill is the mother of present day metal cutting drilling machine. Next, types of drilling machine. First one, portable drilling machine. Second, sensitive drilling machine. Third one is upright drilling machine. Fourth one is radial drilling machine. Fifth one is gang drilling machine. Sixth one, multiple spindle drilling machine. And sixth one is seventh one, deep hole drilling machine. And eighth one is turret type drilling machine. So first of all, we'll discuss about portable drilling machine or hand drilling machine. You can see the sketch here. That is portable drilling machine. It can be carried wherever required, and it is any compact in size. It is of lightweight. It can be held with a hand. You can see that. So it is called as hand drilling machine. Unlike the mounted stationary drilling machines, the hand drill is portable drilling device which is most held in hand and used at the locations where holes have to be drilled. The small and reasonable light hand drilling machines are run by a high-speed electric motor. In fire hazards areas, the hand drilling machine is often rotated by compressed air. The maximum size of the drill that can accommodate is not more than 12 to 18 mm. Okay, next comes sensitive drilling machine. You all can see the parts here. See, in sensitive drilling machine, you all can see the first base. Always see that base is the main foundation on which the whole machine is mounted. So you all can see here, this machine is a small machine designed for drilling small holes cut at high speed in light jobs. The base of the machine is mounted on the floor. This base of the machine is mounted on the floor. Okay. It consists of vertical column. This vertical column, you all can see the vertical column. A horizontal table is situated in front of this column. Okay. A head supporting the motor and driving mechanism, and vertical spindle for driving and rotating the drill. There is no arrangement of automatic feed of drill spindle. Drill is fed into work by hand control. High speed is necessary for drilling small holes. Okay, high speed is required for drilling small holes. Sensitive drilling machines are capable of rotating drills of diameter from 1.5 to 15.5 mm. Next comes upright pillar or round column section upright drilling machine. Pillar or round column section upright drilling machine. This is usually called pillar drilling machine. It is quite similar to sensitive drilling machine, but little larger and has high capacity compared to sensitive drilling machine. That is from 0.55 to 1.1 kilowatt and are mounted on the floor. Drill is fed and work table movements are done manually. This is low cost drilling machine and has a base, a tall tubular column and arm. You all can see this tall tubular column. You all can see this tubular column which is tall tubular column and arm supporting table and arm supporting this table. You all can see this table. Okay, arm supporting table and a drill head assembly. Arm may be moved up and down on column and also be moved in arc up to 180 degree about this column. 180 degree about this column. Table may be rotated at 360 degree about its own center independent of position of arm. maximum size of the holes that can be drilled is not more than 50 mm. Okay, next comes box column section upright drilling machine. Box column section upright drilling machines. So you all can see the sketch here. So first of all, it is given here. This is the base. Okay, bevel gear drive to spindle. This is the bevel gear drive to spindle, first one. And here is the spindle. You all can see spindle with the pointed things. Okay, so base. First of all, we'll discuss about the parts. That is base. It is a part of machine on which the vertical column is mounted. Top of the base is accurately machined and has T slots on it so that so that large workpieces and work holding devices may be set up and bolted to it. Next comes this column. Okay, next comes this column. You all can see here, this is in a vertical position. It is a vertical member of machine which supports the table and head containing all driving mechanism. Column should be sufficiently rigid so that it can take up entire cutting pressure of the drill. Next comes table. It is mounted on a column and is provided clamping work directly on its face. Table may be round or rectangular in shape. Table may have three types of adjustments: vertical adjustment, radial adjustment about the column, and circular adjustment about its own axis. And next comes drill head. It is mounted on the top of the column and houses the driving and feeding mechanism for the spindle. In some of the machines, the drill head may be adjusted up or down for accommodating the different heights of work in addition to the table adjustment. Next comes spindle, which holds the drill, transmits rotation and axial translation to the tool for providing cutting motion and feed motion both to the drill. So thank you for the today's session. I wind up with this now. So if you have any doubts, you can call me. Thank you.